welcome everybody. We had quite a few questions about meetups and conferences, but I'm very interested in the question, who has actually used DuckDB? Good. Yeah, that's like 90% of the room for the video. I'm saying that. So, the title of this talk is DuckDB in a spreadsheet with WASM. And you can see that duck that is showing there, that is an ETF, and it's called the boring duck. So I think this title is very boring. I didn't choose it. It just appeared on the calendar. So let's pick a different title, because I'm doing Python focused demos today. And there is a connection between Python and DuckDB. Who knows what the connection is between Python and DuckDB? So a Python likes ducks for breakfast. Yes, I love that. Yes. Who else? Duck typing. So that's a good one. So if it quacks like a duck, it looks like a duck, it walks like a duck, it's probably a duck. That is a saying in Python when we talk about like how Python types things. So you have duck typing in Python. Yes. Next one. They were invented in the same place, CWI. So they both come from Amsterdam, Python. DuckDB we know, of course, like everybody's here knows the history of DuckDB. But the history of Python is not so well known. That who knew that Python came from Amsterdam? Okay, everybody knew. Okay. Lucky. Okay, so another title I came up with is Ducks Fly Where? Because I'm going to show you that DuckDB runs not just in the environments that you expect, but it also runs in surprising places. So this is a question for you all, like who knows how high a duck can fly? So what is the highest that a duck has ever flown? I want some guesses here. Like you can do meters or feet, that doesn't matter. 2,000 meters. Can I get more? 2001. Come on. 10,000 meters. Oh, very close. So it's 22,000 feet, which is almost 7,000 meters. That's how high a duck has been spotted flying over the Himalayas. So that's why this is the hint there. That's the Himalayas, so it's flying over that. And the duck name is called Ruddy Shelduck. So that's not his name, but that's the brand. No, the kind, what's it called? The species of duck. And it's an orange duck, so again a Dutch connection there. Everything is Dutch here. But I decided on this title, so I'm going to show you how you can use DuckDB in Python in the browser without writing any code. So I'm going to quack by example, just by clicking. So let's see how far we get with that. So this is what I'm going to run. I'm going to have a CSV that I import into DuckDB. DuckDB will emit a Pandas data frame for me because in Python, Pandas data frame is a really nice abstraction to deal with, a data structure. Because many or most of all of the visualization packages in Python actually work with that. And I'm going to render where this duck actually flies. So you can see it starts like to the north of the Himalayas, and in the summer it goes to, or in the winter it goes to the ocean there, and twice a year it flies over this hill, 7,000 meters, just unbelievable. So this is our goal. So how do we get there? First, an introduction myself. I'm not connected with DuckDB, even though I'm wearing a yellow shirt. This is just coincidence. I made a couple PySheets certs. My project is called PySheets. It's on the far right there. I've worked on this similar stuff, data science in the browser, with financial applications at Bank of America and JP Morgan. And I was thinking like PySheets should do something similar like that. The two projects I'm working on right now is PySheets, and then the other one is Lifesaver. And this is the QR code for Lifesaver. So I want to encourage you to actually open your phone and make a picture of that. This is when they teach you like how to present. Like, oh yeah, don't ever ask them to take out their phone, right? But go there, enter your email address, and you get a free copy of my book. So the 6 first people The first 6 people get a free copy of the book. So the race is on. So that is a lifesaver. Has nothing to do with DuckDB. It's just a cool project. So why did I build PySheets? So I'm very interested in running Python in weird places, and one of them is the browser. And when PyScript came out, which is a technology that unwraps both Pyodite and the MicroPython Python VMs to run on WebAssembly in the browser, I thought like, hey, that is cool, I want to play with that. So I built a couple apps on top of that. You just write Python and it runs directly in the browser. You don't have to compile it into WASM or something like that. It's just the original Python code. And you can build UIs like this. So that is one of the things that I wanted to try out. And then the second thing, as I mentioned, I worked at Bank of America and JP Morgan. We worked on large trading platforms written in Python to do financial analysis like portfolio analysis, pricing, risk calculation, and all those algorithms. And there, if you have a dependency graph, that is really nice. It's a nice mathematical abstraction of an algorithm where you have nodes that calculate something and pass on rest of the information to another node. And these nodes can remember their values. So if the inputs haven't changed, then the value is the same. Now spreadsheets work the same way. So this is why I thought like PySheets is a great combination of all of this. So this is a personal art project, and see how far I can get. So what I'm going to give you now is 3 demos. First is LTK. When you see it, you know what it is. Then we're going to do a demo with DataFrames. So I'm going to find the highest airports in the world, which are not as high as a duck can fly. And I'm going to do the same thing in DuckDB. And you can make your own observations and decide who's better. DuckDB has a bigger font here, so it's probably better. I don't know. So what is LTK? So LTK looks like this. So let's go to the real demo. So this is my home page, chrislaffra.com. I wrote this in PyScript, so this is all written in Python. And at the bottom here, you can see it's built with LTK. So this means that if you go to this link, you can actually go here, and I have one loaded here already. So this is the showcase of what you can do with LTK. So this is like Qt or any winnowing toolkit. If you're a Java engineer, this is the Java JWT or similar. TK. So this is like a structural language. So you have a declarative language. It says like, I want a vertical box, and inside I want a text, and then I have a horizontal box, and so on. So this is how you construct your UI. And this is another example. This has a model view controller, so it's reactive UIs. Here I don't have any event handlers. This is all based on basically attaching a field in a model, and then when it changes, it updates the rest of the UI. So why is this special? This is client-side rendered. This is all written in Python. And this is very fast. So if I start this up, so we're here, like I'm constantly refreshing. And you can see the average is around like maybe 90 milliseconds. That's how long it takes to load the page, the HTML. Discover that you want to do something with WASM, so it builds up WASM. Then it loads the Python VM, which is not in the sandbox yet, so it downloads it. It installs it in that sandbox, it runs it, and then the sandbox, the Python VM looks around and says like, what main.py do I want to run? It runs my main.py, and then the UI gets constructed by interacting with the DOM, and that whole process from nothing is like 90 milliseconds. So this is LTK. I wrote that so that I could build the next step. So the next step was building a UI which is a little bit more interesting than the one you see in LTK. So this is like a spreadsheet UI. It has a grid with A's and B's and numbers, so it looks like Excel or Google Sheets. It has a menu bar, so you have things like menus. So you have something like menu bars, anything you would normally have when you build a UI, basically. But again, this is all written in Python. So again, I will emphasize the performance here. So if you refresh this thing, it comes up sub-second, basically. Doesn't look like much, but a lot of engineering went behind this to get it to the speed. So what I wanted to show now is finding the highest airports in the world using data frames, and then with DuckDB, so you can make a contrast, right? So we have a table with all the airports, and that's like 82,000 rows. So this is loaded from the internet. So we download the CSV in the browser app. It gets turned into a Pandas data frame. So we have that in memory now. Now I showed you before like how fast this thing starts up. I'm cheating here because I'm using a Python VM called MicroPython, which is designed for embedded devices. And it's designed to start up really fast. It's only like 240K, everything, to download. And then it starts up like in 80 milliseconds. But it doesn't have much built in. So it doesn't have anything that can run Pandas, for instance. So Pandas is actually running in a worker. So you can see that here on the side, it says worker running Pyodite. And it took like 2.8 seconds. So when I'm starting up, I'm actually starting a worker in the background that acts like a kernel, like if you're a Jupyter Notebook person. But the kernel is actually running in the process as well. So it's running in the same WebAssembly container. And they can talk to each other, so they can pass each other information. So this is how we do the Pandas stuff. So this visualization, this preview, if I refresh this, this is just a picture. And this is drawn by the MicroPython VM, and it goes really fast. In the background, you can see the worker is starting up, and it took 2.8. And now it's still rerunning, and now it reran everything, so we're good. You could have done this all in Pyodite without MicroPython, but it starts up a little bit slower. So that's the flexibility that you have in PyScript by having multiple VMs that you can use for different targets or different purposes. So this one is really big. You can see 82,000 rows. It also has quite a few columns. If I scroll to the right, there's all this useless data. I'm only really interested in the name and the elevation, right? So first of all, I'm going to filter this thing. And again, I didn't know how to do that. I'm an expert Python programmer, but Pandas APIs are a little bit strange. So I just wrote this English text. I said like filter the data frame in A1 and basically show the airports that are higher than 14,000 feet. And it wrote me this code. And I can prove that it actually did, because if I say 15,000 foot and say regenerate, it will regenerate the tables. So this one didn't change, but this one did. And that's the dependency graph again. So memoization happens in there as well. And now I get fewer airports, but I'm interested in more. So let's say 14,000. And I can also fix the generated code, of course. Although there's no round trip, it doesn't update my prompt. I don't know how to do yet. Maybe I have to write an AI that can read Python code and regenerate the prompt. So the next step is, so now I filtered the number of rows. Then I want to basically clean up the data, because it has coordinates in here, somewhere on the right, but you can see they're bundled together. And they're one string with a comma in the middle. And I need let and lon, two numbers. And I'm sure you can do this in Pandas. But how do you do that? I don't know, right? So I just write the English text. This is literally what I wrote when I was sitting down here before the presentation. And I wrote that text in the top. So I said, like, take two columns, add two, and split them, coordinate, and just as a normal person would say this to a junior programmer, go do it. And then the junior programmer comes back with this code. So now I got a cleaned up table. I could also drop some other columns if I really just want to narrow it down, but for now this demo is okay. And then the map, again, this is, I didn't write the code, this is AI generated. So finally I got my map. There's a lot of work here, right? This is like 1, 2, 3, 4 steps. I could do them together, and if you're really good at writing Folium logic. You can actually do it all in one statement. You could do this, but it's not that easy. It's not designed for this purpose. So how is DuckDB doing? So this is the end result with DuckDB. I'm just going to show you the end result, and then I'm going to delete it. And so we start from nothing. So we don't have anything. And I'm going to import my data set. So this comes from somewhere else. So this comes from this URL. It's a CSV. And I get a preview here to validate that it's actually the data that I'm looking for. Yeah, this is great. I can turn this into a Pandas data frame. I can import it into the sheet so it just appears here, or polars if you like. Or, of course, for today we do DuckDB. So now I have, this code is not AI generated, but it's generated by PySheets because it knows how to call the right DuckDB statements, basically. So what do we see here? We see a big table, again, the same data that we saw before. So if I scroll to the right, there will be coordinates. You can see they're still comma separated, so I can't fix that automatically yet in DuckDB. Maybe we can. Huh? But I want to make it a little bit smaller, so I'm going to remove some columns. So I don't need this one. I don't need this one. I want it. Yeah, I want that one. Don't want this one. This one. So I'm deleting some columns that I'm sure I'm not so interested in. So this is really the data that we're interested in. There's still way too many rows. We can see 82,000 something rows. So I want to filter that down. Now, who knows what query to write here? So this is why we are at the talk that is called Quack by Example, because I'm quacking now. I'm writing queries for DuckDB, but I'm doing that by giving an example. So I'm typing in the data set. I look at the values and I say, like, this is an interesting set. And that then goes in and updates the code that was generated by PySheets to basically, yeah, get that value out. So now I have a smaller table with only 21 rows, and then I can take that and visualize it. So again, this is loading with MicroPython. So if I refresh, you can see it's pretty fast. It starts up something in the background. You will notice that it takes a little bit longer now. So now it takes, I don't know, 3.8 seconds instead of 2.8. And that is because we have to also import these packages. So we need fsspec, and we need DuckDB, and we need Folium because we're going to draw a map again. Now, I want to visualize this. I don't know how you do that. So there's an interesting button here that says star A1. So I'll click that. And it inserts a prompt for me that is then sent to OpenAI, and it writes the code. And it visualizes this data set here. So it uses the names and the columns. I don't tell it what to visualize, but the AI will pick it. And it shows us as a graph. So yeah, this is elevation feet. Okay, yeah, there are two that are way higher than the rest. Yeah, I don't know. Doesn't tell me much, right? We want to see a Folium map. So I say as a Folium map, so I just adjust the prompt, and the coordinates are still in the wrong shape, right? So coordinates are comma separated. So I'm just giving some hints to the AI that it probably needs to deal with that. These are the top 21 airports in the world. So this comes out of this query with elevation higher than 14,000. So if I just want to have like the top 10 airports in the world, like how would I express that in SQL? Who knows that? Or by elevation. And okay, yeah, but like I'm AI addicted, so I don't know how to do that. So write me the SQL to show the top 10 airports by elevation. So let's see what this prompt generates. Select name from airport, order by elevation. This, oh yeah. This is probably what you had in mind, right? So we go back to our where clause, and instead of saying elevation, we say order by limit 10. So let's see if this works. And now what we get is only 10 airports. So this is great. So who knows the highest airport in Europe? Which country is it in? Is it the Netherlands? No. Belgium? No? So which country is the highest airport in Europe? Can I get any guesses? Switzerland. Anybody else? France. It's France. So we can do this. Do you know what town? Chamonix. I hear Chamonix, yes. So this is the top 20. So let's do the top 50. Look, at some point it appears. So here it is. So here's Altisovis du Glacier du Dôme. You can also add, of course, in the volume map, you can add the name of the town, so you can see it's actually Chamonix. But it's funny is that you have to go like the top 50 for the first American airport to show up. So America is not much in the high airports, right? They're not winning that game. So what we can do is show the lowest airports. So where in the world are the lowest airports? So I'll remove the descending part, and this should give me the lowest 50 airports in the world. Any guesses? Let's do the lowest 10. Let's look. The lowest 10 might actually surprise you. They may surprise you. It surprised me. So the lowest 10 are in two places, actually in the US. So the US is winning with the lowest airports in the world. Okay, I don't know if you want to win with that, but so this is the Dead Sea. And I showed the elevation as well in the map. Maybe I can do that here. So what is the marker showing? Come on. So the pop-up shows the name. So I want to say elevation feet. I'm just winging it here. Let's see if it works. So if I click on one, it's minus 164 feet. So that is quite deep. So let's do the top 50 or the lowest 50. And then the Netherlands should show up, right? No, not yet. What? I thought it was like really low. Let's do top 100 or the lowest. What is that? The bottom 100? Yeah, and then the Netherlands shows up. So we all think that the Netherlands is low, but the airports are not that low. It's like minus 11 feet. Schiphol is minus 11 feet, so like 3 meters. So we're not winning there yet. We gotta go deeper. Anyway, this shows you the flexibility of DuckDB, because in this one query, we can do all kinds of transformations, filtering, transpositions, whatever, in one query. So this scales a lot better than all the other steps. So I think I haven't really used DuckDB until last week before I started doing this demo, and I'm sold. So this is why I have the sticker here now. So I think, yeah, this is a really cool application of using DuckDB. So how does it work? How it works, it's all Python code. So all the code I wrote, the demo I gave you, it's all written in Python, and it's enabled by PyScript, and it's an open source technology for running Python in the browser using PyDite and MicroPython, which are also open source, using WebAssembly, which is also, everything is open source, and LTK that I used is also an open source project in PyScript. If you're interested in that, it's free. And it runs on top of WebAssembly. So you don't compile your Python code to WebAssembly, but the VMs have been compiled because they're C programs and they're very easy to compile into WebAssembly. I was going to say jar files, but they're called differently in WebAssembly. WebAssembly files. And in the browser, you also have access to the DOM, so you can call any arbitrary JavaScript. So these arrows that you're seeing there, they're not done in Python. So for that, I use a third-party JavaScript library. But you can mix and match. The UI is heavily leaning on jQuery, for instance, for doing the DOM operations and finding things and setting up event handlers. And then DuckDB just works. I was surprised. It just works. Well, not surprised, of course, not surprised. I was happy. It just works. So why did I call this talk Quack by Example? This is all not new. This is all invented in 1975. It's called QBE, so not QB, Quack by Example. It's actually called Query by Example. And it was invented by somebody in IBM Research. And this is an example. So you have a table and you print like P, so you want to see the sailors, and then you give a condition where the rating is 10. So these are two sailors from the 1975 with a rating of 10. So I wanted to build something similar. So this is why I think DuckDB is a great technology, but starting is maybe hard for the typical Python programmer. So I wanted to make it easier to select columns, to set conditions for values. And that's how I came up with Quack by Example. This was 2 days of work to build that table thing. So it's not hard once it's all there. I believe WASM is the future. So the technology stack that you've seen now uses all of this except for this part. But because we're running in WASM sandboxes, they can run in V8 isolates. Cloudflare is one of the vendors, for instance, that uses that, leverages that to a high degree. And the identical code that you write that runs in the browser and does your analytics can also run on the server. This is all, like virtualization is really complete. V8 isolates are way smaller than Kubernetes. So there's a lot of potential here for scaling much more horizontally, but also vertically. So I think like tools like PySheets is just one example. You can build your own or use another one. They explore what kind of data structures you can build. You build a dependency graph and then you deploy to somewhere else. And 5 years from now, everybody's going to use WASM, I think. So the summary, DuckDB loves Python. Python loves DuckDB as long as WebAssembly lets them talk to each other. So I think this is a great love triangle here. So are there any questions?